Okay, cool. All right, guys, so for those of you who are here, what is a logarithm? That's the full name of these things. Logs. The hell is it? What is it asked? Like log base 8, 64. What is that asking you to do?
8 to the what power gives us?
Yeah. 8 to what power is 64? Right? So this is really asking you 8 to what is 64? And of course, what will the answer be? 2. So this is why the answer is 2. Be sure to always tell me the answer.
So it's like how many 8s make up 64?
Yeah, totally. Because what does a power mean? It's the number of things that are being multiplied. So that's why there's kind of two ways to look at it. They're both the same. What power does 8 need on it to become 64? Which means how many 8s multiply to be 64? Now what's the difference between what I just did and this? What's the square root of 64?
8.
8. So this, a root asks you, what does it take this many of? In this case, we know it's a 2 to make this. This asks you, how many of these does it take to make this? So with the root, the power is known. It's the square. With a logarithm, the base is known. It's the base 8. Maybe. Because this is related to x squared. Right, square root is an inverse of x squared, basically. And what is this related to? Who remembers? What's the inverse function of log base 8 of something? I've got it written down already. 8 to the x in general. I like it. So that's why a log finds a power, because it's related to unknown power. Whereas a root finds the base, because it's related to unknown base, maybe. So a lot of what I tell you don't really have to get to be able to do these things. But if you get the full idea, they are easier. Okay, so let's try a few lightning round problems here. So what is log base 16 of 16? 1. What's log base 16 of 4?
1 over 4. Oh,
Almost. 1 over 2. Why? Okay, I like it. 4 squared is 16, so 16 to the 1/2 to invert it, right? Square root of 16 is 4, therefore it needs a 1/2 power. What about log base 16 of 2?
1 over 4.
Yes, because what root do you need to take 16? 4th root of 16 is 2. I can rewrite this as 16 to the 1/4 is 2. That's how you check yourself when you do a logarithm, is you rewrite it and make sure it makes sense. You put a 4 there, it doesn't make a damn bit. It's 16 to the 4th power. Holy shit, that's way more than 2. What about
Zero.
yeah, so see how if it's between 16 and 1, the answer is a fraction because it's a root, but cuts it down and cuts it down and cuts it down. No, yes, maybe so. And then if the minute you get to something less than 1, what's that going to be? Yes?
So how'd you say, like down log 16 to, you said it's 1/4. How do you say you check it?
Right there. You rewrite it. What does this mean? 16 to the 1/4 is 2. Is that true? Yes, the 4th root of 16 is 2. That's how you check it. Okay, and what about this guy?
Is that a negative?
Negative 1, because you don't want to change 16, you just want to flip it. So in between 1 and 16 is a root. A root cuts things down. But then if you want to get below 1, you need a negative power. That's what makes something less than 1. Because it flips it over, makes it a fraction less than 1. It's kind of a neat thing to realize. Do you actually have to understand what I just said? No. As long as you understand how to attack a log, you're fine. Oh, this sounds like a really weird self-defense. Attack the log. It's coming at you.
What if it was like 1/8 instead of 1/16? What would the negative one?
Oh, holy shit. You ready? No, you're not ready. All right. So here's an interesting question. It's interesting on a few different levels. I can't make 16 become 8 very easily. Can you? No, I can square root 16 to make it 4. Right? But so what would make it 8? Oh shit. All right, now watch. So what is the answer? Do you know what the answer is? No. So what do you put when you don't know what it is?
X.
X. Can you rewrite this now?
Take this 16 to X power.
Now, hang on. I am jumping ahead this because I love this question and it's perfect. Can somebody tell me what number are both 16 and 1/8? What number are they both based on? Is there a number they're both based on? They're not both based on 4 because 4 to what power is 8? 8 to what power is 16? No. So what are they based on? 2. I can raise 2 to the what power to get 16?
4th power.
So 2 to the 4th power is 16. You guys with me? So anywhere I see 16 in the universe, I can replace it with 2 to the 4th if I felt like it. All right, so here I feel like it. 8 would be 2 to the
3.
3rd, so 1/8 is 2 to the negative 3rd, because the negative power makes you flip, right? So if 2 squared is 4, 2 to the negative 2 is 1/4. That easy. Okay. So this is 2 to the negative 3. Now watch. What do I do with these? Anybody remember the property? When you raise something with a power to a power?
You multiply.
Multiply. All right, now let me stop here for a second. Now this is interesting. So I was able to base both of these numbers on 2. Do you see why that's important? Now, what's got to be true about 4x and negative 3 in order for this to be true? They have to equal each other. The only way 2 to this can equal 2 to that is if this and that are equal. Do you guys get that? So then that has to equal that. So therefore x is negative 3/4. I knew it was going to be negative because it's 1/8. It's less than 1. I knew it's going to be negative, but it's a weird root power combination. What root do I take of 16 to make it 8? There ain't none. Right? Well, what do you get if you take the 4th root of 16? You get 2. And what if you take 3 2's? 2 times 2 times 2 is 8. 3rd power, 4th root. Hey. So if you can rewrite it and base both of these numbers on the same number, that's actually another way to kind of do it more, sink your teeth into it. Instead of like, what is it? You can do it and see every step where it's coming from. So for example, if I had, what you got, Jeff? Log base 9 of 27. Can you just figure that out? 9 to what power is 27? All right. So what do? And then you rewrite it. How could I rewrite this?
9 to the x power equals 27.
Yeah, 9 to the x. Now what are they both based on? 3. This is 3 squared. This is 3 cubed. So 2x has to equal 3. Do you guys see? If you can make the bases the same, then whatever's up at the power must equal also. So I made the bases the same. So now the powers have to be equal. So x is 3x. To be honest, you could do that with every problem we've done with logarithms so far. So for example, we did this one earlier. Or yesterday. You could say this, you could go this, you could go 2 to the x equals 8. And then watch, you're really silly. 8 is 2 cubed, so x is 3. But hopefully you would know x is 3 right here. You wouldn't have to do it. But the process works. It's just that you don't need to use it unless you hit one of these weird-ass ones. There's not a single thing you do to 9 to make it become 27. There's a couple of things you'd have to do. Okay. All right. So logarithm, the answer to a logarithm is a what? The answer to any log is a power. Logarithms are powers. Maybe. And again, what the hell? What's the answer to this? 3. Because 3 is the power. Okay, there you go. All right. So the answer to a logarithm is a power. So we're going to talk about the properties of logarithms, and the funky thing is they're exactly the same as the property of powers, because logs are frickin' powers. So here we go, watch this. So we're sort of sneaking into 12.4 now. Oh, it's my time, shit. Let's see. You're gonna love this here. So let me see. All right, I'm gonna try to show you some reasoning, and then I'm gonna get to the shortcut way to look at things. So if I have to figure out the log of a product of two things, what is log base b of m? What does that represent?
B to the what power is m?
Yeah, it's the power that b needs to become n. And what's log base b of n? It's the power that b needs to become n. You guys with me? So if I say this is x and I say this is y, how can I rewrite these? Because I don't know what it is, right? So let me just call this one x.
Log b to the x power
B to the x equals
equals m.
m. So it's either fully log form or it's fully exponential form. And then this guy, b to the y equals n. So what is m times n? What's m?
Bx.
B.
B to the x.
By.
And what's n? I like it. And then what do you get here? B to the, what do you do with the powers?
Subtract it.
Mm.
Oh,
Add them. You subtract if you're dividing. Now stay with me now. Stay with me now. I know a lot of what I just did was kind of funky, but at this level you start to see some proofs, a little bit of proof every now and again. I've taken you through a few proofs this semester, and they're nothing you sit there and you're like, I would never think to do that. Of course you wouldn't. You haven't seen them yet. You don't even know what you're allowed to do. You would never think to do this shit. I'm not even being mean to you. I'm just like, I wouldn't think to do this shit if I didn't know math. Damn. But, do you see where this... So I'm trying to figure out what this thing is. How does a log act on a product? Since logs are powers, there's got to be some kind of a power rule, the way there is for powers. What do you do when you multiply like bases? You add the powers. Stay with me now. Now watch. Let me take log base b of both sides. Isn't that what I want to know? What's log base b of b to the x plus y? What happens here?
they cancel.
Yeah, these cancel, so you just get x plus y, right? All right, red. Let me try the other red. All right, let me stop for a second. Again, this is all derivation. You would never have to do any of this here by yourself, ever. I'm going to finally get to a point where that's the rule, and then you can just use it, right? This is where the rule comes from. What was x? It was this. What was y?
Log b to the n.
So look what happened here. When I multiply things with the same base, I add the powers. Aren't logs powers? So I told you, every property of logarithms is the same as the property of powers. What's the power when I multiply things with the same base? I add the powers of each. That's the rule. That is a logarithmic rule. So, real quick, an application of this rule. Log base 12 of 3 plus log base 12 of 4. Can you do either one of those? Think about it. 12 to what power is 4? Holy shit. I can't do that at all. 12 and 4 are not based on 2. No, 12 isn't based on anything. So I can't do either one of these separately, but what's the rule say I can do?
You can add them. Add the
Careful, that is here. Log base 12 of 3 plus log base 12 of 4, I can make a log base 12 of
3 times
3 times 4. Now, of course, what's 3 times 4?
12.
12. And what's log base 12 of 12?
1.
Frickin' 1. I like it. So it feels a little bit, not a lot, but a little bit like putting radicals together if they have the same root. Here, if I have the same base, when do I sum powers? When I was multiplying the stuff. That's how you remember this. So what do you think would happen if I had this difference of 2 logs? When do I subtract powers? When I was dividing. So if I had, I got a handout by the way. Log base b of a, let's just keep with m and n. M minus log base b of n, that would be log base b of m over n. Because when do I subtract powers? When I was dividing the things. So let me give you this handout. It's got, oh wait, you already got this one. It's on the other side of the 12-3 handout. Now, one quick thing I'm going to unleash you on these problems. If I had this log base b of m to the p, that would be log base b of m times m times m times m. How many times?
P.
P times. Right? And what do I do? Again, what was the rule when I had log base b of mn? That was log base b of m plus log base b of n. So I just use that rule over and over and over again. So I'm going to get log base b of m plus log base b of m plus log base b of m. How many times am I going to write that? Total.
How many p is?
P times. Right? So if I have p of these, if I had 2 of these, what's log base b of m plus log base b of m? 2 log base b of m. So how many do I have in a row here? P of them. So what's this? This is p log base b of m. So look at, this is kind of crazy. Well, what does it look like happened from here to here? It looks like the p just came down there, right? What do I do when I raise something with a base to a power to another power? What do I do with the powers? I multiply the powers. It's still a property of powers. You guys are so excited. So here, watch. How can I rewrite natural log of x squared? I can just take the 2 down. That's what that comes down to. And believe it or not, that's actually the most important property of logarithms. We just don't know it yet, except I just told you, so we do. So do the problems on the sheet. Sheet that's got 12, 4 at the top. Let me know if you need this sheet. Yes. Do you need that sheet? No? Do you want a sheet? Do you need it? I'm going to bring it with me. Let's see what happens by the time we get there. You got it. Okay.
Oh, you have to.
Yes.
So what's the front of the universal? So
Say it.
what's the front of the
Oh yeah, no. It's like right here, the 2 can come in. So as long as it's the inside being raised to a power and there's a log, you can just come down. Yeah. Well, that's a combination of all these rules all at once. See how you can use this rule in reverse? See all the coefficients? They can go back up. Then you have a difference of 2 logs. You can make it the log of the quotient. So it's like these properties in reverse. So let's first do this, and then we're going to build up to there. Yeah.